So this is the third video for BCA charts. This one should be really short. If you've not watched the first two, you might want to go back and watch those. But this is just one more example of how to do a BCA chart. And this one just has two conversions. So in this one, it gives you the grams, and it also asks you for grams. And so you just have to convert those numbers both into and out of your BCA chart. So here's our problem. A plant produces 27.8 grams of glucose, and you probably remember from biology that's C6H12O6. What mass of carbon dioxide did it remove from the air? And then this one went ahead and gave you the balanced equation, since you might not remember that one. So if you've got your balanced equation, you remember that's rule number one. We're ready to go. Always start with the balanced equation. Since I always have to have moles in my BCA chart, I'm going to have to convert this number into moles. So I'm just going to come down here below the BCA chart. I've got 27.8 grams of glucose, C6H12O6. And I need to convert grams into moles. Do you remember from when we did the mole conversions? Moles always, if you are using an unconversion, it's always 1 mole. For the conversion factor. You might start with something or end with something different. But in the conversion factor, it's always 1 mole. And so then I just need to add up my mass for the glucose. So I've got 6 carbons. So 6 times 12.01 plus 12 hydrogens. 12 times 1.01. If you see hydrogen's mass here, just round it to 2 decimal places is fine. And then I've got 6 oxygens. So 6 times 15.999, I'm going to round that to 16.00. And you get 180.18, if you can see that or not, for the mass. So 180.18 grams in 1 mole of glucose. And so then it's just a matter of doing one more little calculation here. So 27.8 divided by 180.18 is 0.15429, etc. I've got 3 sig figs there, so I'm going to call that 0.154 moles. So that's what can go in the BCA chart. Now that tells you that the plant has produced that much glucose. So that is your product here. But in order to get that, because I always start out with 0 of my products, I had to add 0.154 moles. So once I get a number here in the change line, we said everything else in the change line follows that ratio. So everything else is a 6 to 6 to 6 ratio. So let's figure out what amount of moles that I've used there. So it's 6 times this amount. So I divide by 1, multiply by 6. So 0.154 times 6 is 0.924. Again, sorry, can't see that too well. 0.924 moles. And so from the products I have used up 0.924 moles. And again, I don't have to do every calculation because your coefficients there are the same, so these numbers will be the same. Now, as far as filling in the rest of the BCA chart, you can do whatever you want to. You can call this exactly 0.924 moles. Or you could say you had excess carbon dioxide. It's coming out of the air. There's excess available. That's not that big of a deal. You're going to have, or you do have what you need to answer that question. But you can do it like that, or you can say excess with those. And you get 0.924 moles of oxygen gas produced also. Now, that has filled out our BCA chart, but it's not quite answered our question yet. So the question is, what mass of carbon dioxide is coming out of the air? So the air has lost 0.924 moles. I'm going to come back down here to do a conversion. And that is CO2. And now I need to convert moles to mass. So looking back at the periodic table and finding my mass for carbon dioxide. For carbon, let's clear that out. I've got 12.01, there's one of them, in carbon and CO2. And I've got 2 oxygens, 16 times 2, I can do that one in my head, 32. So 44.01 is the mass. And then to solve this one, I'm multiplying 0.924 by 44.01. And I get 40.66524. 3 sig figs give me 40.7 grams. And of course, this is your answer. This is your grams of CO2. So again, I just want to do that one last calculation where we had conversions going in and coming out of the BCA chart. Nothing different fundamentally, but just want to give you an opportunity to see kind of everything that you're going to run into there. So move on to those practice problems. Let me know how I can help you. I will see you next time.